let's start by looking at the Claire Evans BMI example data. When she did an application of this in that first paper, we're going to reanalyze the data, fit the same key models, but do we have a little bit more space here to do a kind of a wider range of graphics and descriptive statistics, and to go into some finer detail of some of the modeling a little bit more as well. But we'll start off by looking at BMI and individual level variation. So the data have some 33,000 respondents, and the key socio-demographic characteristics, the 5 of them, are sex or gender. It was only coded male, female, race or ethnicity, which is going to be white, black, Hispanic. That's American data. Education, there can be 4 levels of that. Income, there's going to be 4 income bands, and age. 4 age bands as well. We'll see the definition of those shortly. So I might get my crayons out at this point and use the wonderful annotate tools in Zoom to do this. So let's pick a nice yellow highlighter. So here's a data frame for the first 3 individuals in the data. So this is like the spreadsheet of data and how you might organize your data and what it looks like for this analysis. So the rows are the individuals. So we have the individual 1, individual 2, individual 3, and you might have a variable storing an individual identifier there. And we call that the level 1 identifier. Later on, we're going to go multi-level. The response or outcome variable is BMI, body mass index. And the first 3 individuals you can see here are their BMI scores. And then we have level 1 covariates, characteristics of the individual as they're currently conceived. And here are 5 variables: sex, race, education, income, and age, 5 explanatory variables. And so the first individual with their BMI of 32.7, they are male, Hispanic, high school educated, low income band, and young adult, 18 to 29. We have a bit of notation as well. We index individuals mathematically with the subscript I equals 1, 2, 3, up to 33,000. The outcome is denoted Y sub I, so the outcome for individual I. And then our 5 explanatory variables are X1, X2, X3, X4, X5, all with I subscripts because they vary across the individuals. So I have to clear my annotations at this point, and then I can shift on to the next slide. So let's start by looking at a histogram of the BMI, the outcome variable. Remember, we've got 33,000 individuals, so this is a nice histogram of their BMI scores. And what we can see here is we've got a positively skewed distribution. I'll draw an exaggerated version of it. So we've got a long right tail. Okay, the skew is not that bad. It's a slight skew, really. You could do a log transform of that outcome, would be one way to reduce the skew before modeling, but it's sufficiently slight that I'm willing to kind of stick on the original scale, which is actually easier to interpret parameters. But choices like that have to be made just as they have to in any regression analysis. So the mean BMI 27.9. So remember, 25 is overweight, 30 is obese. So this is 28 really. And it's an American sample rather than European, so there's a higher prevalence perhaps of obesity, 29% in these data, and with 65% overweight. Okay. Here we are now looking at the 5 characteristics in some detail. And we are looking at the frequency distributions, really, or the percentage breakdown of individuals across each, the categories of each variable in turn. So the 5 variables are sex, race, education, income, and age. Within sex, we've got people who said they were male or female. What's interesting here is that females are some 60%, pushing on 60% versus 40% for males. So clearly this isn't a random sample. Perhaps this reflects different response rates. Perhaps women are more likely to respond than males. Clearly, you really want to get a handle on that. I'm just commenting on that for now. More generally, there was actually, it wasn't intended to be a random sample. There was systematic oversampling of young adults, Hispanics and blacks as well. Yet in the analysis by Claire Evans and co-authors, there wasn't in that analysis an adjustment for sampling weights. So it'd be interesting to explore the importance of that. There's an argument that you might not necessarily need to worry too much, because ultimately the analysis we're doing here is not averaging over categories. We're ultimately doing such a nuanced analysis that we're getting a separate set of results for every subgroup of individuals. And so the weighting is perhaps not such a big issue. But nevertheless, there are clearly methodological areas of exploration which can be done with intersectional MAIHDA. So ethnicity, we've got some 61% white, about 20% black and Hispanic. Education, we move from dropout through to degree, and as well there. And then income bands, we've got, you can look at the original paper by Evans to see the definition of those. And then we've got age categories as well. So let's proceed to the next slide. So we now got the same 5 variables on the x-axis and all the categories again, but on the y-axis, rather than saying what percent of individuals are in each category, I've now got the outcome, body mass index. And so we now got the mean BMI in each category. So here's our first citing, really, of the nature of inequalities. So for gender, mean BMI is very similar. Women have slightly less mean BMI. But for ethnicity, you've got big differences. So the traditionally kind of marginalized group, most marginalized group here of African Americans has got the worst outcomes, whilst what would normally be considered the privileged identity of white in these discussions has the best outcome in terms of lowest BMI. Likewise, in education, as we move from the most marginalized to most privileged, we have better outcomes. Most marginalized group financially to the most privileged group financially, better outcomes. But for gender, women would be viewed as more marginalized in these debates in general, and men more privileged, and there's no difference there. But obviously, what we mean by marginalized and privileged identities kind of depends on the outcome we're talking about, which, so for BMI, it'd be different for wages. Ages, you might think the most privileged group, probably 45 to 59-year-olds in terms of those with power in society, they've actually got the worst outcomes. And the least powerful group, perhaps it's the youngest, or pushing or want to get into retired as well, but they've actually got the best outcomes. So there's different kind of patterns here in relation to what is perceived as marginalized and privileged identities. So let's clear out those annotations and shift onwards.